Good evening, my lovely warriors. Time to study everything about multiple pulleys, your wedge constraints, multiple pulley block systems, and all the confusions and all the complexities we are going to discuss in today's session. It's a very quick session, so let's keep it that way and let's get straight to the point. So all those students, be it 11th, be it 12th, and be it the dropper students, if you are facing issues or problems with constraint motion, I'm going to explain you the theory and I'm also going to solve problems right from easy to advanced level. Alright, so let's get started with me, Shreyas, your physics master teacher, and I'm going live at your favorite Vedantu Enthuse channel. Hi Shrikant, hi Ajay, and if you are here, do not forget to mark your attendance by welcoming everyone, saying hello and greeting all the lovely friends that you are going to make on this channel. Those of you who do not know me, well, I have been teaching on this channel for quite some time. I have also worked with many offline institutes. I have produced many ranks and I know what it takes to get into IIT, and I am going to cover all the important topics which you need before entering the 12th standard. So if you are a 11th standard student, this session is must for you. And our aim is to make sure that each and every kid improves. It's not just about the toppers, but even a student who is getting even 0 marks, or even a student who is getting 20 marks, or even a student who is getting 60 marks has the right for quality education. And I'm going to make sure that your marks improves no matter what, because every result is a story, and that's what we believe in, that's what I believe in, and that's what we are going to strive for, the real achievers. And we had thousands of real achievers last year, thousands of stories in JEE Mains and Advanced. Now next year it's going to be your turn too. So have you hit the subscribe button? Have you hit the like button? If you have not, go smash the like button. Hello, bless see. So are you guys ready? And how many of you have been facing issues in this constraint motion? What kind of problems you have faced issues with? Please let me know. Hi Chicken Baba SPM, welcome bacha log. So let's begin with the session. Here's the first question coming up on your screen. Hi Vishal, join in bacha log. Find the acceleration of the not the light pulley, actually it should be of mass m. So I'll just rewrite the question over here, just 1 second. All right, find the acceleration of the mass m if the pulley is light. If the pulley is light. Let's see how many of you can do this, and I will put up a timer of, let's say, a minute. Come on, let's see. This is an introductory question just to get you into the mood for constraint motion. Even without the knowledge of constraint motion, you can solve this. Good evening, Solar. Wow, why is your name Solar? Solar? Is there something to do with solar energy, or is it something else? Suchi Mama, welcome. Let's get going. Good evening, bachalog. It's almost evening, Vishal. Yep. Okay. See, think about it. Analyze the situation. Draw the free body diagram. It is a very cakewalk, easy peasy, lemon squeezy question. You can get it within few seconds. Still, I have given you 1 minute time. Even if you're watching this recorded, make sure you pause and solve the question. Do not just skip to the solution part. Dakshin, good evening, bacha. Let's see how many of you can do this. Okay, hardly few seconds left now. Okay, Kiran, welcome, bacha. 5 seconds. Hello, Arjun. Hello, bacha log. 2 seconds, and the time is up. Okay, I'll tell you how to solve this question if you guys got confused. First of all, draw the free body diagram of the pulley. So, if you draw the free body diagram of the pulley alone, you will notice for that pulley, you have a force F right at the center. The string is wrapped over it, and the string will obviously encounter certain amount of tension. Since it's one single string, obviously the tension will be same throughout the string. The pulley is massless or light. That's something you should keep in mind. Because of that, what will happen, even if the pulley has certain amount of acceleration, okay, even if the pulley has certain amount of acceleration, I can easily say for this pulley mass system, F, the net force is MA, F minus 2t, F is that side, 2t is this side, is equal to mass of the pulley into acceleration. Since the mass is 0 into acceleration, no matter how much it has, 0 into any number is 0. Therefore, you will see taking 2t on the other side, F is equal to 2t. Many students forget that when you have a pulley and you put t over here, and you put 2t over here, that is applicable. That logic is applicable only when the pulley is light. If the pulley is not light, then F minus 2t is m into acceleration of the pulley. Only when the mass is 0, F is 2t. Is that making sense? Understood, Suchi Mama? Only in that case. Now, notice on that mass m, the only force which is acting is T apart from the normal and the mg force. That's it, right? So this mass is definitely going to have certain acceleration. So if I do the same equations for m, you will say T is equal to m into a, but T is nothing but from here T is nothing but F by 2 is equal to m into a. Therefore a is nothing but F divided by 2m. Hence the correct answer will be F by 2m, which is nothing but this one. So this option is correct. Got it? Everybody clear? When is it 2t, when is it not 2t, when you have to make sure that F is 2t? Only when the pulley is massless. Correcto Solar, very good. Hi Simran, welcome. Hello Ilyana Fahima, welcome Bacha Log. Now let's go to some really cool constraint motion problems, but I'm going to teach you 3 important methods. Very important methods. Sometimes you can use all the 3 methods, sometimes only one method is useful, sometimes you can use 2 methods. So I will teach you 3 methods. It's up to you which method you want to use, and it also depends on the problem type. You will get to know which method to use when you solve at least 20, 30, 40, 50 problems, not before that. So if you say, sir, after this lecture I will understand, no. If somebody has told you that, they are also lying. Only after you solve quite a few problems on your own, only then you'll understand when to use what. I have been practicing for a long time, so I know what to do when, but still I will explain you the logic on what I'm thinking, and then I will show you when to use what in the problems ahead. First method that I want to teach you is via, something called as visualization. Then I will teach you the derivatives method. Then I will also teach you, a tension method by a work done. First, let's start with visualization. These are 2 masses, M1, M2, 2 pulleys. You want to find the relationship between the accelerations or velocities of the 2 masses. In visualization method, you need to draw, or if your visualization is strong, you can imagine it and then directly, without writing even one line, even one equation, you can directly give A1 is 3 times of A2 or V1 is 7 times of A2, whatever it is, you can write it directly if your visualization is strong. And I will teach you how to visualize. Okay, it takes a little bit of practice. I will start with drawing first. Now this pulley is fixed, everybody agree? This pulley is fixed, correct? But this pulley is movable. So whenever you have movable pulleys, try to move the movable pulley and see what happens. So for example, let's say I move this pulley a little bit up. So I will show the new position. Observe this. I will show the new position and I will show it probably over here. So this point will now come over here. So the pulley has gone up by amount X. The pulley has gone up. Earlier the center was over here. Observe this. The center was right over here. The center has gone up by X amount. If that's the case, even this mass which is attached over here, the mass will also go up. So even that mass will go up. So I'll show the new position of the mass, M2. So M2 also has gone up by X. Now the moment that happens, hello Alishan, K Ashish, welcome Bachalo. Okay. What happens over here and here? Observe. Do you see that the string was actually wrapped over the pulley on the white side before? On the new diagram, the blue one, the pulley, the string has to be wrapped over the pulley over here. Do you see the strings here and here are extra? These are basically extra strings, extra elements. They are just hanging, right? They are just hanging. But if you want the string to be tight, then obviously you need to pull that. You need to pull it across so that the string wraps perfectly around the blue pulley, which is the new position. So what will you do? This string and this string, each of these elements have a length of x. If this is x, this is also x. Because if the pulley goes up by x, mass goes up by x, 2xx amounts of string are free. To make it tight, you wrap that pulley with that string. Okay, pull it. Make sure that the 2x goes over here. Finally, it goes across this pulley, and that means this mass has to come down by how much amount? 2x amount. Got it, everyone? Everyone clear? Ganesh, there are a lot of videos. In fact, yesterday's video, I did, all the most ignored topics and the question series. I've been doing sprints and mock tests. Please keep a track of the mock tests and the sprints which are going on, Ganesh 54. Okay. The changes need not be dx, it could be delta x, it could be x, it could be y. It need not be infinitely small. Even if it is big, it is okay. Okay, Suchi Mama? Alright. So if displacements are in the ratio of x and 2x, or 1:2, even the velocities will be. That means if the velocity of this mass is v and the acceleration is a, then the velocity of this mass will be 2v and the acceleration will be 2a. So I found out if this is a, this is 2a. If this is v, this is 2v. If this is x, this is 2x. Why? Because if it moves twice in the same time, obviously it will have twice the velocity and twice the acceleration. I hope this is clear. Everybody clear about this? Shall we go ahead? Everyone? Everyone clear about this, my warriors? Okay. Ready for method 2? Okay. Everybody ready for the method number 2? Observe this now. Now this method will use derivatives. Okay, we'll try and use the derivatives method and see how it works. Whenever you make use of derivatives method, always remember one trick, and the trick is always measure the length of string using assumed variables from fixed points to moving points, from fixed points to moving points. What does this statement mean? Okay, see, you can observe that there is exactly one string here. Although this string is there, it is useless, it's not doing anything. This is the main string. Measure the total length of the string using some variables, assumed variables, and make sure that the length which you are assuming, the variables that you are assuming, one of it is fixed at a point, the other one is probably at the moving end or so. Observe this now. First of all, I'll tell you what it means. See, the length of the string L, can I write it in terms of some assumed variables? And I think I can. Observe this. From here till here, I can assume this as x. Can I assume this much part as x? It's a variable height because when this pulley moves, this x also varies. Everybody can see that. And when this pulley moves up and down, understand that this distance is also going to be x and it is also going to change. Everybody agrees? Now this distance obviously is fixed, so let's say I call it just d. From here, from the center line till this roof, this distance is always going to be fixed. This is a fixed point to a movable point, fixed point to a movable point. If this is x, this is also x by symmetry. You can see that. Everybody clear about this? Okay. Now this is not x. A lot of you might think, sir, this is x, this is x, this is x. No. This is not x because this mass need not be here. It could be here, it could be here, it could be anywhere. So I will just assume this distance as some y. I hope this makes sense. This is just some y. Now last things over here. This is some string wrapped over here. There is some string wrapped over here. Let's say if this is d1, this is d2, and this is d3. Why am I writing it as d1, d2, d3? Reason, this D3 or D2 will not change even if this mass goes up and down or if this pulley goes up and down, because the amount of string which is wrapped on that part of the pulley always remains fixed. If it is basically a semicircle, whether the pulley goes up or whether the pulley goes down, same amount of string will be wrapped everywhere. Everybody agrees to this? Everybody agrees to this? Cool. Why have I marked all these variables? Because this statement says write down the length of the string using some variables. So I assume some variables here. Now I can write the entire length of the string making use of these variables. Observe this how. The length will be D1 plus X plus this distance, which is D3 plus X distance plus D2 plus Y. This is the total length of the string. This plus this plus this plus X plus D2 plus Y. Very good. Now the next step is crucial. That is where derivatives come in. Differentiate both sides with respect to time. So what am I trying to do? Differentiate both sides with respect to time. Reason, you will see why. When I do this, dl by dt, oh by the way, this entire expression will become like this: d1 plus d2 plus d3 plus 2x plus y. I'm just collecting all variables of same kinds on similar sides, and 2x is there, x and x is 2x, and one of the y is there. So here I will have d by dt of d1 plus d2 plus d3 and derivative of 2x plus derivative of y. L by dt, dl by dt, that's 0 because the length of the string never changes. This is very, very important to understand. This length is nothing but a constant. So the moment it is constant, the derivative will be 0. Even d2, d3, d1, all these things, this length and this length, they're all going to be constant. Derivative of a constant is 0. So this entire term will become 0 plus derivative, this 2 will come outside, dx by dt. What is the meaning of dx by dt? Rate of change of the pulley's position with respect to a fixed point. X is the separation between a fixed point and the pulley. So if dx by dt is asked, dx by dt is rate of change of the position of the pulley, which means it is nothing but the velocity of the pulley. Is that understood, everyone? Okay, so I'm just going to mention it over here that in this situation dx by dt will represent the velocity of the pulley. If I ask you what does dy by dt represent, dy by dt represents the rate of change of position of this mass m1. So it is velocity of mass 1. As simple as that. So hence I will just put over here dy by dt is nothing but v1. But I'll tell you something. The pulley is directly attached to the mass. If the pulley is directly attached to the mass, means wherever the pulley moves, the mass m2 also moves along with it. Hence, velocity of the pulley is velocity of the mass 2. So Vp is equal to V2. Hence, instead of writing Vp, I might as well write this as 2 times of V2, 2 times of V2 plus V1. Rearranging it further, V1 will be minus 2V2. The moment you get minus, you should understand that if one of the velocity is down, the other is up. That's what it signifies. But magnitude wise, V1 is nothing but twice the magnitude of V2. Hence, acceleration of 1 is twice the acceleration of 2. Hence, this guy has twice the acceleration of 2, which is exactly what we got. Okay. If 2 pulleys of same size are attached to a single rope, will the Sushi Mama, it does not matter on the size of the pulley. All that matters is whether it's a single rope or not. If it's one rope, then the tension will be the same. Remember that. Okay, if it's a single rope, as long as it is a single rope and the pulley is massless, it will always be the same tension. Is that understood? We still got the same answer. If this was A, this was 2A. Here also, what did we get? If this is A, this is twice of A. M1 has twice the acceleration of 2. Everybody clear about this? Hello Manas, welcome. So I have taught you 2 methods. Are you now eager to learn the third method, which is very quick? And first of all, tell me, didn't you find this method very lengthy? Many coaching institutes, many books recommend this method, but I don't really recommend this method unless and until it is very much required. I would prefer doing it by visualization. Look at visualization method. You just have to think, oh, this goes by X. Oh, 2 strings got free. Oh, those 2 strings have to be pulled to make the string tight. So this mass goes down twice. Very easy. I will teach you third method, which is also very good. And this will also change your perspective of things. Observe this now. Okay. Now, in the third method, we will make use of the fact that the string is inextensible. String is inextensible, and because of that, what happens is no potential energy is not stored in it. And if there is no potential energy stored in it, that means the net work done on the string, or basically work done by the forces acting on the string, is, okay, I'll just 1 second, write it properly. Work done on the string is going to be 0. The net work done on the string is going to be 0. Okay, so observe this carefully and let's try to solve the question. First of all, when you look at any system and you want to solve it by the third method, all you need is to mark the tensions first. Only then you can proceed with the problem. Now, this is very obvious that if this string has a tension of T, then this string, because it's the same string, this will also have T, this will also have T, and obviously this string over here, this will have a tension of 2T. Correct? This string, if this is T, this is T, this will be 2T by the same logic what I explained you before. Okay, so if you are talking about on the mass 2, where the string is attached over here, the tension will be actually not upwards, it will be downwards. Where did I put it? Okay, so this basically on this point over here on the string, it will be like this. This will be 2T. If you talk at these points, then the tension on the string will not be like that, because the tension on the block will be like that, but on the string, obviously the tension will be this way. At this point, the tension will be like this. Now, just look at the end points of the strings. Look at the end points. This is one end, this is one end, and this is the last end over here. That's it. Okay. Now, why not kinetic energy? Very obvious. String is light. If string does not have mass, how much kinetic energy will it have? Obviously 0. Now just write down the total work done by all the points where the forces are applied. This is 1 point, this is 1 point, this is 1 point, and let us assume that this point, okay, this point, if it goes up by X, this point comes down by Y amount. Just assume. Obviously, if this goes up, obviously this will come down. This goes up by X, this comes down by Y. Just assume it. Now, if I ask you what is the total work done, here is what you are going to write. The work done at this point is 0, because here you have no displacement. No displacement over here. So work done by that point is 0 at that tension. Understood? Work is force into displacement. Force is there but no displacement, so work done is 0. This point, tension is there, displacement is there. So what is the work done? It will be force into displacement, which is Y. And it is positive because force and displacement are in the same direction. Cool? Is tension same at all the points in the string, Arjun? Yes, because it is one single string, that's why the tension is same. But here, this is different string, and here if this is T, collectively it will add up to become 2T. Using the same logic which I told you in the first question. In case you are joined in a little bit late, just rewind back and watch the starting question. Got it? Now over here, tension is down, displacement is up, so negative. Force into displacement, opposite directions. So this will be minus 2T into X. This will be equal to 0. Now shift it on the other side. Therefore, Ty is equal to 2Tx. Therefore, Y is equal to 2X. That means, what did you get? Y is twice of X. That means, if this goes up by X, this will come down by 2X. which is exactly what we got in the previous slides. If this is x, this is 2x. If this is v, this is twice of v. If this is x, this is twice of x. Exactly the same thing. So this is very useful method. In fact, you can do it even in a much shorter way. I'll tell you how. All you need to do is, in the much shorter way will be, if on M1 the tension is T, on M1 the tension is T, and on M2 the tension is 2T, then exactly invert the coefficients of tension. This is T, this is 2T. So acceleration of 1 will be 2a and acceleration of M2 will be a. If this is 1:2, this will be 2:1. Inverse ratio. So basically this method is nothing but acceleration is in inverse ratio of the tension along the motion. Very, very important. If this is 1:2, this will be 2:1. If this was 2:3, this will be 3:2. That's it. Is that understood? Very good. Excellent. Okay, great. Let's move on now to some questions coming up on your screen. It's up to you how you want to solve it. Yes, this method is the easiest. Relationship between velocity of block 1 and block 2. Look at this, 3 pulleys, but only 1 pulley is fixed. I think other 2 are movable. Okay. Is it valid only for constraint motion? No, Dakshin. It is valid for any motion, because string is a string, whether it is constrained or whether it is not constrained, because no energy can be stored in an inextensible string. Very good, Sri Krishna. I'm so happy. Yesterday you were telling about your practicals. So happy. Join in the session because a lot of things you are going to learn. Okay. Observe this question and think about it. What is the relationship between V1 and V2? The logic is very simple. You can use any of the methods. I will definitely not prefer derivatives because it is going to go crazy. It's going to go berserk. I mean, imagine x1, y, I don't know, z, x minus y, y, z. I don't know. It will be crazy, guys. I would definitely not prefer the derivatives method. Visualization, yes, maybe. Say you assume that this goes down. If this goes down, where will this go, etc. You can do that, definitely. But still it will be crazy because if this pulley goes up, then you have to think about how much string will be remaining. It's little bit complicated. I would not even prefer visualization method. I would prefer the tension method. Observe this now. If this string has T tension, because this is the same string, how much tension will be there? Obviously, this will be also T only. Everybody agrees? Okay. Next. If this is T, this is T, how much will be this? This will be obviously 2T, and the same string is connected over here. So obviously, this will be also 2T. I hope this is agreed upon. This is 2T because this T plus this T will give you 2T to balance it. And the same string continued, so same tension. Lastly, you have over here this string connected over here. If this is 2T, this is 2T, how much will this be? 2T plus 2T down will be balanced by 4T over here. So the same 4T will continue over here. Fair enough? Okay. Now, what did I tell you? Let's say I write for block 1. This is for block 1. This is for block 2. This is tension. And here I will write acceleration. For block 1, what is the total tension? 4T plus 2T plus T. So for block 1, it is 4T plus 2T plus T, which is nothing but 7T. For block number 2, only one tension force is there, so only T. What did I tell you about acceleration? It is exactly inverse of the ratio of the tension. So if this is 7T, this is T, this will be 7A, this will be A. Or basically even for velocity, this will be 7V, this will be V. As simple as that. So V is V2 and 7V is V1. So essentially what did I get? V1 is 7 times of V2. That's the exact relationship. Very good, Ashish. Excellent. I can see your changed logo. Very good, Bacha. Suchi, Dakshin, you too should change your logo, display picture. Yep. So this guy's velocity is 7 times the velocity of this guy. Isn't it simple method? You just have to count the total tension on that block, total tension on the other block and take the inverse ratio of it. It is not totally, it is not 1:2 or 1:3, it is 7:1, and you can see that 7v1. I think over here it was given ulta. Guys, ignore this. It was supposed to be the other way around. Okay, so v1 is basically 7 times of v2. Okay, I think everything is fine over here. Cool, everybody? Great. Oh, I'm not sure why, Suchi Mama, you have to go and change it. Yes. Okay, chalo. Let's go ahead with the next question then, coming up on your screen, and here it comes. Now in this situation, you have a string at an angle. Many students get confused, but let me show this to you by 2 methods. Everybody ready? I'm going to show this to you via 2 methods. Observe this carefully now. So meanwhile, you can post the answers in the comment section. Method 1, via visualization. And visualization is the easiest one. Trust me on this. If this point is moving with velocity Vp, obviously the string is also coming this way with a velocity of Vp, because it's the same string which is going there. Same string is going there. That means this point along the string has a velocity of Vp. Fair enough? Vp. Okay. Now simultaneously realize this point is actually connected to the block, and you can see this point, actually speaking, is going this way along with the block with a velocity of Vb. Now comes the big debate. Sir, is Vb equals to Vp cos 30, or is Vp equals to Vb cos 30? Is it the first one or is it the second one? Come on, let's debate it out. Post it up in the chat section. Which one do you think is correct? Yep. No need of force balances, just constrained motion. Come on. Is Vb Vp cos 30 or Vp is equal to Vb cos 30? Guys, it's very easy. I'll tell you what. This point is actually moving there or actually moving in the direction of B. Think about that, because you need to understand who is whose component. Who is whose component? This block actually is moving here. So all the points are actually moving here. So Vb is the actual velocity of that point. A component of it is Vp. There is also another component here. You can always split a vector into 2 perpendicular components. So Vb is the main vector and you have to split it. So hence this is correct, this is wrong. Vb's component is Vp. Understood? It's the second option. It's the second option. No, Anthony, just try to check your resolution. Okay, understood? Whenever you have a vector, how do you split it? If this is the main vector, this is component 1, this is component 2. Component is the main vector's cos component, or component 2 is the main vector sine component. So you split the actual vector. This is the actual vector. Now it's simple. So Vp is equal to Vb. Cos 30 is nothing but root 3 by 2. So Vb obviously has to be 2 times Vp by root 3, which obviously has to be option D, I suppose. Yep, it is. Okay, this is one way of doing it. Another way of doing it is via tension. Observe this carefully. If this point has a tension of, okay, this point has a tension of T, even this point has a tension of T only, because it is the same string. But what matters, I'll just go back and show this to you. The tension along the motion, this is very crucial. Acceleration is in the inverse ratio of the tension along the motion. So the tension along the motion, what is the tension along the motion? It is nothing but T cos 30. T cos 30. Now it's very easy. So this is for A, this is for B. Sorry, not A and B, my bad. It's P and B. For P and B. For P, the tension is T, correct? This is for P and B separately. For point P, the tension is T. For block, the tension is T cos 30. That's what it is, correct? So the velocities or accelerations will be exactly inverse. So for P, the velocity will be V cos 30, and for this guy, it will be nothing but just V. If this is 1:cos 30, this will be cos 30:1. So that's it. This will be equal to Vp, this will be equal to Vb. As simple as that. You can see you will still get the same answer. Understood? Yes, of course, Suchi Mama, but you don't have to wait till the last chapter of maths for learning vectors. You should learn vectors independently. The vectors which you learn in maths is way more different and way more mathematical than the application part. So the vectors which you use in physics is more of components, resultants, cancellation, additions and subtractions. Okay, clear everyone? Moving on to the next question coming up on your screen. Very good, K. Ashish. I am going to make sure you are going to master constraint motion after today's lecture. You will never ever cry about constraint motion after this. Observe the next question. The question is again find the relationship between the velocities of the blocks A and this one over here. Okay, so actually we have to find the velocity of block A. Okay, so we have to find this velocity. So if this point is actually moving down with velocity V, that means the string will be going like this with the velocity V. If the string goes over the pulley with velocity V, then this point will be going like this with the velocity V. But is this point's actual velocity V or is it actually 50/3? Think about it. This is a bead or a ring which can slide over that rod. So that means all the points on the rod, be it this point, be it this point, be it this point, or even this point, all these points move with the same velocity of 50/3 meters per second. This is the actual velocity. That's it. Now your job is done. If this is the actual velocity and this angle is 53 degrees, so it means V is actual velocities cos 53 degrees. This is actual velocity. You split it. This V in the yellow color is the component of it. All right. So hence, what is cos 53, guys? You all know it, right? Cos 53. It is nothing but 3/5. 3 goes, 5 goes. So only 10 is remaining. So 10 meters per second is the answer. Done. Very good, Sundarajan. Hello, Abhishruti. Welcome. Hi, Jagdish. Very good, James. Very good. Cos pass. Yes, the trick which I gave you, Suchi, long time back. Answer is 10. Isn't it simple visualization? Everybody got it? Excellent, Riaz. Moving on to the next question. Oh my God, scary. Did you guys get scared? Please don't get scared. Don't disappear from the video. We are going to solve this within minutes. Within seconds, we are going to solve this question. And let's see how to crack this question right now. Here it comes. The question says, velocity of block A is 1 meters per second. And then you have these strings which are going around and this block B is there. The question is, what is the velocity of block B? I will use derivatives. Nah. Should I use visualization? Nah, I can, but nah, no. Tension? Yes. And see how. This is T. Only one string is there. Do you see that? Only one string is there. So if this is T, this is T, this is T, this is T, this is T. At this point, the tension is T. At this point, okay, let me use some other color. At this point, the tension is T. At this point, the tension is 2T. At this point, the tension is 2T. Why? T and T together give 2T. That's it. Now, just write things down. This is for block A. This is for block B. For block A, the total tension is 2T plus 2T plus T, which is 5T. For that block B, the tension is just T. So, velocity, if this is V, this is 5V. This is 5V, correct? But whose velocity I know? I know the velocity of block A. Velocity of block A is 1. If this is 1, this will be 5 into 1, which means it is 5 meters per second. Done. Option D is correct and we are absolutely correct. Yep, it is. That's it. Done. Isn't it simple? After this, you will never face any problem. Are you loving it? Go smash the like button down there and go hit the subscribe button for more such tricks. Yes, I will be doing, Jagdish. Rod and wedge constraints are also coming. Moving on to the next question. If mass capital M has an acceleration of a I cap, then what's the acceleration of small m? Interesting question. Okay, let's try and do this first. Okay, there we go. Now let's how do we do it? Do you want to do it by constraints, or do you want to do this constraints problem by visualization, derivatives, or work? I don't know, it's up to you. I feel visualization might be much better over here. I'll tell you why. You can do it by work and attention method also. I'll just redraw the situation. I'll just make this mass move slightly. I'll just make this mass move slightly and see what happens. Okay, so this mass will move here slightly like this by distance of x. If this moves by x, this point will come over here. So you got x amount of string free, goes like this, like this. Oh, this pulley is also there. This pulley is also there. Okay, one sec. Let me draw it nicely, guys, so that you can visualize it. This pulley is also there. Oh, look at this. This string is also there. So where are the extra strings? This one is the extra string x, and this one is the extra string x. Where will this string and this string go? It will obviously fall down, and you will notice that it will go like this. It will go like this, and this mass would have come down. So how much will the mass come down by? Think about it. How much will this mass come down by? Very easy. Yes, similar question is there, but many people fail to understand how to solve that. Hello, Laddu Singh. Sir, classes for 11th to 12th moving. This is for 11th to 12th moving. Shanu, you are JEE 2023. You are watching the correct lecture. Yep, open your eyes. Yep, this is going to be 2x. Very good, bacha log. Excellent. That means if m goes with acceleration a like that, then small m will come down with how much acceleration? 2a. So acceleration of m will be 2a but downwards, so minus, and if that is j, this is minus j. So that's why minus j cap. But there is one small catch, many people forget it. This mass has also moved forward. Do not forget that. This mass has also gone in x. You just found out the y component, so it also has gone forward by a acceleration, so a I cap. This is the final answer. This is the final answer, a I cap minus 2a j cap. Did you understand why? Because it has also gone ahead by x and it has come down by 2x. So if you look at the displacement, actually it is like this. It has gone here by x and it has come down by 2x. So this is the resultant. This is the resultant motion. This is the resultant motion of small m. Everybody got it? Everybody got it? Understood? Clear? Yep. So that's how it is. Excellent. Let's move on to the next question. Find the acceleration of block M. Assume pulleys are massless and frictionless. Okay, this is straight away direct question. I want you guys to solve this within a minute. I'm also going to start solving. If you don't want to watch my solution, if you're watching it recorded, pause it and then see the solution. Or if you're watching it live, probably you can replay it later or just see the final answer. Let's do this. Okay, first of all, mark the tensions. Easy, super duper easy. This is tension, this is tension, this is tension, this is the same string, this is also tension, and this will be 2 times tension. Okay, fair enough. Now if this is t, this is 2t, we know that acceleration is inversely proportional to the tension along the motion. So that means if this is t, this is 2t, that means this will be a, this will be 2a, correct? This will be 2a. T 2t, 2a, a. Inverse ratio. Done. Next is just draw the free body diagram properly now. There will be tension here, there will be mg here, there will be normal here, but those won't matter. If there is 2t on this 2m, there will be also 2mg downwards. Now let's start writing the equations first for m and then we'll write it for 2m also. So for m block, for M block, there is only one force, which is tension, and that tension will be mass into acceleration. For 2M block, 2mg is down, 2t is up, that means it will be 2mg minus 2t is equal to 2m into A. Take the value of tension, substitute it here, so therefore 2mg minus 2 into 2ma is equal to 2ma. Therefore 2mg will be equal to 2 to the 4, 4 plus 2 will be 6, 6ma, mm goes, 2 goes, so A will be nothing but g by 3. But g by 3 is there, but let's see what do we have to find. Acceleration of the block of mass m. Acceleration of m is going to be 2a, do not forget that, which is nothing but 2g by 3. And acceleration of 2m is going to be a, which is g by 3. So we have been asked acceleration of m, hence I will mark 2g by 3. Many students make a mistake and in a hurry they mark g by 3 in that excitement. It is option B. Very good. Excellent. Many of you have got the correct answer. I am very happy about it. Very happy about it. Okay, let's go to the wedge and the rod constraints. I will give you two quick methods to solve the problems and you will never face a difficulty in wedge and rod constraints. Okay, let's get started. First of all, whenever you see a rod problem or a sphere is there or some cube is there or anything like that, then for any rigid body, okay, if this is a rigid body, remember if you take any 2 points, let's say this is P1 and let's say this is point P2 and there is a separation of R between these 2 points. Now if it is mentioned or if it is known or if it is assumed that velocity of point 1 is V1 and I don't know, let's say velocity of point 2 is nothing but V2. What you should do is split the velocities first. Split the velocities along the line joining the 2 points and perpendicular to the line joining the 2 points. So if you split the velocity, it will look something like this. There will be one velocity which is V1's parallel velocity or along, I can say V1 along, and this will be nothing but V1 perpendicular. Similarly, V2 will also have a component here, V2 along, and here you will have V2 perpendicular. Now remember, for any rigid body, the distance between any 2 points is always going to be the same. It will never change, else it will never be rigid. That means the relative velocity between 2 points, along the line joining them, will always be 0. They will always have no relative velocity. Else if they have relative velocity, the block will expand, contract, it will change the shape or size. There cannot be any relative velocity. Hence, I can clearly say that V1 along should be equal to V2 along. That's it. These two components will be same. That's the logic which you should use. This can be Kavya, this chapter as such, you cannot call what is the weightage of this particular concept. This concept can come in work power energy, it can come in electromagnetic induction, it can also come in electrostatics, it can come in Newton's laws, it can come in rotation. So that way it can come in any chapter as a combined concept. The next important thing which you should remember is for wedge related problems. So if you have two surfaces, okay, this is surface 1, this is surface 2 in contact. So whenever you have two surfaces in contact, what you should do is look at the velocity at the point of contact. Let's say this point, it has a net velocity, split that net velocity, let's say this has velocity V1, split that velocity into two components. This is velocity of 1 perpendicular to the surfaces. If this is the tangent, this will be the normal, and this point will also have another velocity which I can call it parallel. V1 parallel, V1 perpendicular. That's the velocity of the point on surface 1. Similarly, take another point on surface 2 which is in direct contact. That will also have certain velocities. Maybe, I don't know, it has a velocity like this, let's say. So split the velocities again into two components, V2 perpendicular and V2 parallel. The idea is, if the two surfaces are in contact, that clearly means the velocity along the normal has to be same. Because if two points are in contact, how can they have relative motion? If they have relative motion, then they will not be in contact. If two surfaces are in contact, they should have same velocity along the normal. They can have relative sliding. When two surfaces are sliding, they are still in contact. So the parallel velocities don't matter. What matters is the normal velocity. If those perpendicular velocities are different, they would no longer be in contact. Hence, the correct answer will be V2 perpendicular is equal to V1 perpendicular. That's it. Is that understood? Clearo? Amazingo? Perfecto, guys? Understoodo? Let me know in the chat box. Every time, thank you. No problem, Kavya. So much. Okay, great. How to know which one is perpendicular, which one will be along? Suchi Mama, draw the common tangent. See, whenever you have two surfaces, let's say these are the two surfaces, this is the common tangent. This is common tangent. Draw the common tangent, the one which is perpendicular. This is your perpendicular. That's it. Got it? Okay, fair enough. Okay, let's do some questions based on this. Wow, what a question. We have a rod. There are two inclined surfaces. The rod is going to slide. The rod is going to slide like that. The question is, find the relative motion, find the relation between the velocities at these 2 points. Let's try to figure this out. Let's call this point as point A. Let's call this point as point B. Now, how will each of these points move? Let's try to figure out. This point, because it is in contact with this surface, obviously needs to have a velocity like this. So I will call this as VA. VA, because this point has to move in contact with this surface, so it has to have VA velocity. Perfect. This point will move along this surface, so obviously it will have a velocity VB over here. Perfect. Okay. Now what did I tell you just some time back? If there is a rigid body, the velocities along the line joining them should be the same. That's what I told you, right? The velocities along the line joining the 2 points must be equal. So I know the two velocities. I know this rod is rigid. So take the components of these velocities along the rod. So if you do that, it's very simple. This component, if this angle is alpha, this will be VA cos alpha. This velocity along this line, if this is beta, obviously this is also beta, that will be VB cos beta. This is that line joining 2 points. So along this line, the velocity should be same. So velocity along should be basically same. Hence VA cos alpha should be equal to VB cos beta. That's it. That's the answer. I hope this is clear. Understood, my warriors? Did you guys get it? Cool. It's so easy. Before this, probably this question could have looked very difficult, but all that I have used is this concept. Nothing more, nothing less. Okay. Let's do one question on wedges as well. Okay. What is constraint motion? Motion which is related, which is, confined. It is dependent. If this moves, that has to move. If that doesn't move, this does not move. If this moves this much, this has to move that much. Any motion is constrained. Even take the example of a simple pulley. take the example of this simple pulley and this mass. This is also constraint motion, guys. This is also constraint motion. Why? Because if this moves down by x, this has to move by x. It's related. It is confined. All right. So that's what a constraint motion is. Understood, my warriors? Clear, Abhishek? Clear? Okay, Suchi Mama. Okay. Zeph, probably can post your doubt after the session ends. I'll definitely help you out. Now in this question, you can do by the method which I told you over here. This one, right? Because two surfaces are in contact, so their perpendicular components are same. Or you can also use some visualization to solve it. Like for example, if you notice, this rod, once it comes down, it will slide this wedge B. If rod comes down, so if this point comes down like this, the wedge will go there. Now if this comes down like this, with let's say VA velocity, you need to check what is the velocity perpendicular to the surface. So you need to check this component. If this is 37, even this is 37, correct? Even this angle will be 37 degrees. So this will be VA cos 37 degrees. I need to only check the perpendicular components. Remember, V perpendicular to the surfaces are same. That's what the logic says. So now, for this particular wedge, think about it. Think about it. This wedge is moving towards your right. So the point in contact is actually moving this way. So this angle being 37 degrees as usual, because if this is 37, this is also 37, and that velocity is VB, what is that perpendicular component? What will be that perpendicular component? Think, it will be VB sine 37. Got it? That will be the perpendicular component. Now it's simple. VB sine 37 should be equal to nothing but the VA cos 37. So basically you will get VA by VB will be sine 37 divided by cos 37, which is tan 37, which is 3 by 4. That's VA by VB. That's your answer. And I think, yep, velocities ratio, acceleration ratio, same thing, 3 by 4. Okay, you have to find acceleration ratio. This will be also equal to acceleration of A upon acceleration of B. Same thing. Okay, got it? Everyone? There is also one more way of solving this. I will just show that to you, just so that we have explored different ways. Just move this block, this wedge right side, and bring this block down. So let's say this block comes down over here like this. So it has come down by some amount, let's say X. That means this wedge has to go somewhere here like this. So it has moved some amount, let's say, or else I can just probably make this as Y and this as X, horizontal, vertical. Okay. Now, if this has come down by Y, that means this point also has come down by Y, this point also has come down by Y. Now look at this right angled triangle. Look at this right angled triangle. You guys tell me what is the height of the right angled triangle? Obviously this comes down by Y. Obviously the height of this right angled triangle is Y. If the wedge has moved by X, obviously the base of the right angled triangle is X. So if I measure what is tan 37, what is tan 37? Y by X, right? Isn't it Y by X, guys? So that's it. What is tan 37? It is 3 by 4 is Y by X. Now what is Y? Y is the displacement of A. X is displacement of B. So it will be also velocity of A upon velocity of B, which will also be acceleration of A upon acceleration of B. You will still get the same answer. Okay, J. Kevin, I will check. I'll definitely check. Yep. So this is what the same thing. Yeah. So you saw I have solved so many questions by different methods. I have kept a homework question for you. Make sure you solve this and post the answers in the comment section. I'll be putting up the solutions of this in our Telegram channel definitely. Okay, so make sure if you have not yet joined the Telegram channel, join it. And yep, do not forget to check all the courses that are running for you for 11th to 12th, for 12th standard crash course and the droppers course as well. So no matter when you watch, you can always find a course running for you at the right moment, be it CBSE, be it JEE, be it NEET. And make sure you use the coupon code SHHPRO so that you get the maximum discount possible on all the Vedantu courses. That's it from my side. Thank you very much. And I'm so happy that you guys have tuned in. And if you missed the class for any reason, make sure that you watch the entire thing again right from the beginning, because after this class, you will never have any issues. That's it from my side. Thank you very much. Leave the comments in the comment section. I'll be definitely reading them. This was Shreyas here signing off. Hasta la vista.